All right, we're going to begin this 1988 AP Calc BC multiple choice part of the exam in this video. All right, and I'll give my usual disclaimer of double check whether the content in this exam is actually covered in AP Calc BC when you're taking it, okay? There might be some problems that aren't relevant anymore, or there might be problems that, the topics that they don't have in here, don't test in here that you might need to know. Okay, so I'll leave that all up to you. This is just for the purpose of practicing problems, okay? Let's begin. The area of the region in the first quadrant enclosed by the graph y is x, 1 minus x, and the x-axis is, okay, so I solved most of these problems beforehand, right? So if we didn't even have the sketch yet, so I sketched it, but we have x, 1 minus x. If we expand it out, it would be x minus x squared. We know this is a parabola that opens downward, and it has zeros at 0 and 1. Okay, so that's how I drew the sketch. Once again, zeros at 0 and 1. Okay, that's how I got those two from here. And I know that since there's a negative sign in front of the x squared, it's opening downward. You can even plug in x's half. You'll see that at some point up here. So it'll look like this. Okay. So area is just upper curve minus lower curve. Upper curve is the parabola, lower curve is the x-axis. So it's just integral from 0 to 1, x minus x squared dx. Remember, this is the parabola, okay? This is just parallel, half x squared minus a third x cubed, evaluate from 0 to 1. And you just plug in the upper bound. That's these 2 points. Okay, so half minus 1/3. When we plug in 0 for the lower bound, these will both go away. So it's half minus a third, which is 3/6, minus 2/6, which is the 6th. Okay, 11's A. This guy, you can do a substitution to solve this integral, which is what I did. You could simply just expand this guy out to x to the 4th plus 2x squared plus 4. Then distribute the x in, and then do the power rule for each of those terms, okay? Or we can do a substitution where u is x squared plus 2. I want to substitute in here because du is 2x dx is the signature of x dx, right? So it becomes, we have to change the limits of integration. When x is 0, we plug in here, u is 2. When x is 1, u is 3. So it becomes, this guy is just u squared, x dx, that is du over 2. So du divided by 2, put the over 2 out in front. This again is just power rule, so it's half times u cubed over 3, evaluate from 2 to 3. So we combine these two constants, that's the 6th. 3 cubed is 27, 2 cubed is 8. So this would be 19, so 19 over 6. Okay. F of x is ln of square root x, then f double prime x is what? Okay, so we can rewrite f as ln of x to the half power. And then by properties of logs, we can pull this half out in front, half ln x. If you don't do this and you just differentiate here, starting from here, and you just chain rule carefully, then you'll still get the same answer. But I noticed that we can make this a little nicer. When we differentiate this, it's just half times 1 over x. Okay, so we want to find the second derivative. That would be, this is a constant, so we leave that alone. Derivative of this guy would be negative 1 over x squared. Okay, so that is minus half times minus x squared. So it looks like b. Okay. This one I did not solve beforehand because this one looks easy. u, v, and w are non-zero differentiable functions. Then derivative of uv over w is, so we need quotient rule and product rule. So what's the quotient rule? Bottom d top minus top d bottom over bottom squared. So it should be something big over w squared. Okay, so we probably can eliminate a already. Okay, so let's do quotient rule. So bottom d top, derivative top, we need product rule. So that's first d second plus second d first. So first d second plus second d first, okay? Minus top d bottom, so u, v, That's top. What's d bottom? That's just w prime over bottom squared. Okay, so which one is that? That looks like E. Yes. Okay. Okay, so this one I solved a little bit of it already. So let f be the function defined by this guy. What values of x is f not continuous? So remember the definition of continuity. Okay, if the limit as x approaches to a, f of x is f of a, then it's continuous, okay? Here it's piecewise, so we have to even break it out into limit from the left and limit from the right. So I didn't write the whole limit notation here, but I did what's the limit as x goes to 0 from the left of f, that we approach this curve, 0 from this curve, sine 0, that's 0. How about 0 from the right? We approach 0 from this curve, that's 0 squared, which is 0. So since these two limits are the same, the limit exists, okay? And the limit is 0. Now what's f of 0? That is this guy, because this x is equal to 0 in this row, right? So it'll be 0 squared, which is 0. So it's continuous at 0. How about at 1? We do the same exercise, 1 from the left. We traverse this curve, that's 1 squared, which is 1. 1 from the right, we traverse this curve, which is 2 minus 1, which is 1. F of 1 is 2 minus 1 again, which is 1. The limit exists, and the limit is equal to f of 1. Okay, so it's continuous at 1 also. How about the last point here at 2? The limit as x goes to 2 from the left, we traverse this curve. 2 minus 2 is 0. 2 from the right, we traverse this curve. 2 minus 3, which is negative 1. Limit from the left does not equal to limit from the right. The limit does not exist. So it cannot be continuous at x is 2. So 5 is C. Okay. If y squared minus 2xy is equal to 16, then dy dx is equal to, here we need to implicitly differentiate. Okay, so here's the original problem. Derivative of y squared is 2y times dy dx. Here we need product rule. Let's lump the 2 with the x together. So it'll be first d second. So that would be minus 2x dy dx plus second d first. So second d first. Derivative of negative 2x is just negative 2. So negative 2y is equal to 0. We solve for dy dx. So we move this 2y to the other side. We can factor the dy dx and then divide by what's left over after the factor, which is 2y minus 2x, okay? So that's this guy. We can factor a 2 from everything. So be like this, right? But 2 over 2 is just 1, so it's y over y minus x. So that is C. Let me double check. Yes. We have this improper integral from 2 to infinity. Dx of x squared is, so I can even just solve it here. Antiderivative of 1 over x squared is minus 1 over x. We evaluate from 2 to infinity. This is not the most proper notation, but this is multiple choice, so it's fine. Okay, it's minus 1 over infinity minus 1 over 2. Okay, so this guy would be 0, and we are left with positive half. F of x is e to the x, then ln of f prime of 2 is, well, what's f prime? F prime is just e to the x. So f prime 2 is e squared. So ln of e squared is 2. Okay. Which of the following pairs of graphs could represent the graph of a function and the graph of its derivative? This looks kind of like E. If so, derivative is slope of the tangent line. It's increasing, and it's very steep. So that looks like that. This one clearly cannot be f prime because, well, at this point, at this relative max, the derivative is 0, so it should have been 0 there, so it cannot be 2. Okay, so we can eliminate all the choices that say 2. Now how about 3? This is a relative max, so there should be a 0 there, which it is. The function's increasing, derivative is positive. Function's decreasing, derivative is negative. So this looks like it could be true also, so it looks like it's 1 and 3. So it should be D. Okay, this one, limit as h goes to 0, sine of x plus h minus sine x over h. This looks like the limit definition of the derivative. It's one of the other notations, not the limit as h goes to... Actually, this is the same notation. So this is just the derivative of sine x, which is what? Cosine x. So 10 is D. Okay, so if x plus 7y is 27 is the equation of the line normal to the graph of f at the point 1, 4, then f prime of 1 is what? Well, this is the slope of the normal line. We want the slope of the tangent line, which is the negative reciprocal. So what's the slope of this line? Let's find it. Let's get it in slope-intercept form. So this is the equation that they give us. Let's solve for y. 7y is 29 minus x. Y is 29 over 7 minus 1 over 7x. So the slope of the normal line is negative 1/7. Tangent line, as I said, is the negative reciprocal. Actually, I'm not sure if I said it yet. It's perpendicular, so it's the negative reciprocal, which is 7. Number 10. Particle travels in a straight line with a constant acceleration of 3 meters per second. If the velocity of the particle is 10 meters per second at time t is 2, how far does the particle travel during the time interval when its velocity increases from 4 meters per second to 10 meters per second? Okay, this is a mouthful, but the key things I grabbed were acceleration is constant, 3 meters per second. And they give us an initial condition for velocity. So we probably want to find the function for velocity. And then how far does the particle travel during the time interval when velocity, this is probably integral. Okay, so let's first find the velocity. Acceleration is 3, it's constant. Velocity is the integral, so it's 3t plus c. They give us v of 2 is 10. Okay, that's what this whole phrase over here was. Okay, so v of 2 is 10, which is 3 times 2, plug in t as 2, plus c. So c is 10 minus 6, which is 4. So v of t is 3t plus 4. Okay, now they're asking us how far does the particle travel during the time interval when its velocity increases from 4 to 10. Okay, conveniently, we found the velocity is 10 when t is 2, and the velocity is 4, we know, when t is 0. We plug in t is 0, we got 4, right? So that's what I wrote over here, okay? So we just integrate from 0 to 2, that's the time interval that we want, of the velocity, 3t plus 4 dt. So this is equal to power rule 3 over 2t squared plus 4t, evaluate from 0 to 2, which is 3 over 2 times 4 plus 4 times 2, okay, which is 6 plus 8, which is 14. Okay, so once again, we first found the velocity, and they gave us the initial condition, so we can find exactly what the c is. Okay, so v of t is 3t plus 4. Now, as for the time when velocity is 4 and the time when velocity is 10, well, they gave us the time when velocity is 10, that's t is 2. How about what value of t is velocity 4? That's when t is 0, that's easy. Okay, so it's the integral from 0 to 2 of the velocity, which is 14. Okay, let's move on. All right, here we have sine of 2x's, which is the following series. So what's the Taylor series for sine x? we know that is, you should memorize this, that's x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, so on and so forth. Okay, so sine of 2x, wherever there's x, we just plug in 2x. Fifth over 5 factorial plus so on and so forth. Okay, so it looks like it would be B, and that's right. Yep. Or if you know what the general formula is for sine, you could just plug in 2x as x and you could have gotten the same thing. Okay. All right, this one's very easy. F of x is integral from 1 to x squared, square root of 1 plus t cubed dt. The f prime of x is, this is just fundamental theorem calculus. So it'd be 1 plus, we plug in the limit as the variable. And then we need to differentiate the upper limit, which is x squared. The derivative of x squared is 2x. So it's 2x root 1 plus x to the 6th. 14th. Okay. For any time t greater than or equal to 0, the position of a particle in the xy plane is given by x is t squared plus 1, and y is ln of 2t plus 3, then the acceleration vector is, okay, so each component of the vector is the x and the y, of course, respectively, okay? So we can find the acceleration of the x in the x direction and the acceleration in the y direction, and then just combine them as a vector. Okay, so x is easy. X prime would be what? 2t. Okay, x double prime would be 2. So we can eliminate these two choices already because the x coordinate does not equal to 2. Okay, so now let's find y double prime of this guy. So y prime is 1 over 2t plus 3 times 2 by the chain rule. Okay, we can even rewrite it as 2 times 2t plus 3 to the negative 1 power. So y double prime would be minus 2t plus 3 to the minus 2 power times 2, okay, which is minus 2t plus 3 to the minus 2 power, which looks like e. Okay, let's continue. Okay, this is a classic integration by parts problem. I can tell right away. Did I solve this beforehand? I did not. Okay, so let me grab a piece of scratch paper. This is integration by parts. So we can do the tabular method. That would be very quick in this case, but I'll just do it the long way. Okay, we let u be x. By the way, you can watch my crash course on integration by parts video if you don't know how to do this. If you don't know how to pick u as x. Okay, dv would be e to 2x. V is half e to 2x. So there should be dx there. Okay, so our integral becomes uv minus v du. So half x e to 2x minus half integral e to 2x dx. uv minus integral v du. Okay, so this is easy to finish solving. That is just half x e to 2x minus half times another half e to 2x plus c. So we can write this as half x e to 2x minus the fourth e to 2x plus c. So that is, which one? A. Okay. This is a partial fraction decomposition. I could tell right away. Okay. So we can rewrite this as, so remember 3 over x minus 1, x plus 2. We can write it as some number a over x minus 1 plus some number b, x plus 2, multiply both sides by this denominator. 3 is equal to a times x plus 2 plus b times x minus 1. We plug in easy numbers like x is negative 2. You can watch my crash course on integration by partial fractions. Okay, plug in x is negative 2. This would go away. 3 is equal to negative 3b, or b is equal to negative 1. We plug in x is 1. That's the other easy number because this will go away. 3 is equal to 3a. A is equal to 1. Okay, so we can rewrite this integral as integral from 2 to 3. A is 1, so 1 over x minus 1. B is negative 1, so it will be minus 1 over x plus 2. Okay, I plugged in a and b here. Dx, so the integral of these are both logs, so it'll be log of x minus 1 minus log of x minus 2. We have that from 2 to 3. Okay, or we can even write as log of x minus 1 over x, this should have been plus 2. Evaluate from 2 to 3, So that, what is this? This would be ln of 3 minus 1 is 2. So it would be 2/5 minus ln of 1/4. Okay, and we can rewrite this as log of 2/5 divided by 1/4, or 2/5 times 4, which is log of 8/5. So it should be D. That's correct. Okay, so we just had to be careful about properties of logs at the end to get a matching answer. Okay. If 3 equal subdivisions of -4 to 2 are used, what is the trapezoidal approximation of this guy? Okay, so I believe I worked this out. Yes, over here. So if there's 3 equal subdivisions, remember there's an easy way to calculate the delta x. That's b, or the width, right? So it'll be b minus a over n is equal to 2 minus -4 over 3. N is the 3 subintervals, which is, that would be what? 6 over 3, which is 2. Okay, so these are your intervals, -4 to -2, -2 to 0, 0 to 2. Okay, so we just apply the trapezoid rule. So there'll be a trapezoid here, a trapezoid here, a trapezoid here. So it would be, okay, so there's a half here, so I move that to the outside, okay? And then the height is 2, okay? It'll be, since you have to multiply average of the bases times the height, that's the area of the trapezoid. So the height is the same for each of the intervals, so I also move that outside, okay? So half is from here, 2 is from delta x, and then I just did, oh, okay, so my notation's wrong here, so let me just do it one more time. Okay, so once again, delta x is 2 minus -4 over 3, which is 6 over 3, which is 2. So let me draw it once again. Minus 4, delta x is 2, so it'll be, minus 2, and then 0, and then 2. Okay, these are your intervals. So remember, trapezoid is base 1 plus base 2 over 2, the average of bases, times the height. Okay, so we're going to add up the areas of 3 trapezoids. So it would be f of minus 4 plus f of minus 2 over 2 times 2 plus f of minus 2 plus f of 0 over 2 times 2. Okay, and then plus f of 0 plus f of 2 over 2 times 2. Okay, so this is the average of bases. The height is the delta x. This is the height of the trapezoid, okay? So this is the this area is approximately equal to this, right? So these would cancel, right? So we are left with f of -4 plus f of -2, or f of -4 plus 2f of -2 plus 2f of 0 plus f of 2, okay? Which is equal to, f is e to the minus x over 2. So it would be e to the 4 over 2, okay, plus 2 times f of 2. This 2 and this 2 here would cancel, so it's just e squared plus 1, because it would, this 2 and that 2 would cancel. F of 0, so e to 0 is just 1, okay? Plus e to the minus 2 over 2, okay? Hopefully I did that right. Then that answer is it looks like E. Is that correct? Yes. Okay, I'll finish 19. 20 is epsilon delta definition. I'm not going to do that, so I'll finish 19 and call it apart. Okay. Polynomial p of x has a relative max at -2, 4, and a relative min at 1, 1, and also a relative max at 5, 7. No other critical points. How many zeros does p of x have? Okay, so we can even sketch how this looks. So key things are polynomial, that should signal continuity and differentiability. Okay, relative max, relative min, relative max. We even sketch how it looks real quick. Okay, so at -2 and 4, there's some max, right? At 1, 1, there's some min. Okay, and then at 5, 7, there's some max again. Okay, so how many zeros does p have is what it's saying. Okay, so first of all, another key is no other critical points. So since there's a relative max and or min at these points, that means they were critical points at x is -2, 1, and 5. So when we do our first derivative test of f prime, we have these intervals. Okay, so when x is much less than -2, what's happening? So this was a max at this point, so derivative had to change from positive to negative. This was a min, right? So it had to change from negative to positive, and here's a max, it had to change from positive to negative, okay? So we know that f was increasing all the way up until -2, okay? So there must be some zero there then, okay? Then it decreases to the min at 1, so it'll be like this then. And then it increases to the max at 5, like that. And then it decreases again to infinity, okay? So there's another 0 there, so there's only 2 zeros, okay? 19 is B. Okay, hopefully that made sense. Once again, to recap, this says that there is a relative max min at these points, meaning there should have been critical points at x is -2, x is 1, and x is 5. No others, okay? So in the first derivative test, we know that since this was a relative max, the derivative changed from positive to negative, min, derivative changed from negative to positive, max, positive to negative, okay? So we know that since we sketched it, we just connected the lines. We know it had to increase all the way to the max, then it decreased down to the min here, and then increase to the max, and then decreases infinitely, okay? So hopefully this was helpful. Please look out for the next video. Please give this video a like if it helped you out in any way. Okay, and please subscribe to the channel to get notified for the next